Okay, so again, we did this yesterday and I just gave you some time to see what you knew on your own. Who can tell me where they started or what's something that you like for sure know about this unit circle? Avery, where did you start?
I started with like the 4 quadrants, so from 0, 90, 180, 270.
Good. So my quadrant angles are those like cross angles. Basically, if you think of this as an XY coordinate plane, it's your X and Y axis. So Avery gave me all of my angles, 0, 90, 180, 270, and then 360. Which again, if you weren't here yesterday, those still make sense because if you start at 0 and we go 90 degrees, we go another 90 degrees, like every time you hit one of those, it's been a 90 degrees. And we go all the way around in a circle. Okay, what did we do next? What's another thing that we can do? Avery, keep going.
I did the 30s. So I added 30 from 0 to get the one right above it.
Good.
And then I subtracted 30 from 180 to get 150.
Good.
And then I added 30 from 180 to get 210. And then subtracted 30 from 360 to get 330.
Good. What Avery is referring to by doing the adding and subtracting is she's using 30 as a reference angle or a bow tie angle. You guys remember talking about those yesterday, reference and bow tie angles. If you forgot or if you were new, I put these on your notes right here. So maybe I would go right down here. I'm going to write reference angle or a bow tie angle. Bow tie is what I call it because that's what it looks like, but the math definition would be a reference angle. Basically, and that's why I have these little arrows still on my board, that is the distance from that positive x-axis. So you're either going up from the positive x-axis or you're going down from the x-axis, and those are my reference angles. So if I saw an angle over here, in like this third quadrant space, I'm going to complete the triangle by dropping a perpendicular or by like completing my right triangle to that horizontal, that x-axis. And then this is my reference angle right here. This would be like my 30 degrees, but technically I started at 0, so it's 180 plus 30 degrees. That's that reference angle of 30 degrees. It's really 110, but it's reference angle. It's small angle of a 90 of a right triangle would be 30. Same thing if I were to come down here. If let's say this is also a 30-degree reference angle, I would drop a perpendicular to the x-axis. And technically that would be almost to 360, but I went 30 short. I went almost to 360, but I went 30 short, which is why it's at 330. Is everybody doing okay with that? In the first quadrant, my reference angle is just the angle that it is. So like this is just that like 30 degrees or 45 or 60 or 50 or whatever. And then in the second quadrant, same thing. We almost went to 180, but we didn't. It's 30 less, which is how we got that 150. Okay. Those are my bow tie angles. Okay. Now that we've done our 30-degree angles, what would my next angle set be? Avery?
45.
45. Avery knows what her angles are. I will say Avery's doing a nice job of putting them just in order too. So one thing that you can do, like we did yesterday, I did everything with the quadrant angles and then I did everything with 45. Instead, she's like, let me get all my degrees down and then I can come back and do the other pieces. Also notice that when you do it this way, it makes sense. We went from 0, we went to 30, then we went to 45. Like as we go around the circle, the angles are getting bigger. That's what I call a common sense check. Okay. What would the top left, what would that 45-degree angle be? 135. What about the bottom left? What would that 45-degree angle be?
220.
225. And then the last one? 350. Okay. And then last, let's do our 60-degree angles. First one is 60, second one is, third one is,
240.
and then third one is, good, 300.
Yeah.
300. I like using colors, so that's why I trace those lines. So all of my like blue lines have a reference angle of 30. So I got them by either adding or subtracting 30 from 180 or 360. My green ones are all 45. So I got them by adding or subtracting 45 from 180 or 360. The pink ones are 60. I got them from adding or subtracting 60 from 180 or 360. Okay. Okay, cool. We got all our degrees. What do you guys want to do next? Ordered pairs or radians? Ordered pairs. Okay, what ordered pair do you know?
So one on the right, one on 0.
Good. Do you remember why we use one?
Cause you're going right. Or something.
We're going right one, and it's because it's called a unit circle. So if you say like a unit circle or like, we don't do it a lot in our level of math, but like if you're like in engineering, they'll talk about unit something, and it's just like I've decided that whatever we're doing is 1 unit. So everything is 1 unit away. So my quadrant angles are all left or right or up and down 1. You're not moving left or right any. What would the top one be? What would my ordered pair at 90 be? 0. Good. What about at 180? Good. And then what about 270?
0, negative.
Good. We only did one other unit or one other ordered pair. That was 45. Does anyone remember what was at 45? Good. Square root 2 over 2 was the x. What was your y? Good. The same thing. If you either don't remember or if you weren't here, just be patient. I'll remind us why we did those numbers in a minute. But for right now, just accept those are the numbers for 45. Now, those are the exact same ordered pair. It's always going to be root 2 over 2, root 2 over 2, all the way around. But as we go to like other quadrants, it's going to be different, positive and negative. So when I go to 135, is that x going to be positive or negative? Negative. Is the y going to be positive or negative? Positive. Root 2, negative root 2 over 2, comma, positive root 2 over 2. What about for 225? Is good, negative, negative. And then what about for 315? Positive, negative.
Did you say that 135?
Was negative, positive. And that actually makes sense if you remember how just coordinate planes work. It's the same thing as like the XY axis that we've done before. In my first quadrant, it's always going to be positive, positive. In the second quadrant, it's always going to be negative, positive. In the third quadrant, your ordered pair will always be negative, negative. And in the fourth, it will always go positive, negative. That's something you can do to check. We haven't done the other ordered pairs, so we can't do those. Now we got to do radians. To help us remind our friends who weren't here, what was my conversion I told you about radians? 1 pi radian equals what? Oh, okay. Going from degrees to radians is the degree times pi over 180. Very good. My general conversion factor, Jess, is 180 equals pi radians. So what we did is we took all of the degrees essentially in the first quadrant and multiplied them by pi over 180. And then we kind of use our fraction knowledge and some patterns to figure out the rest of them. At any point, though, you can always use this. Like you could sit here and do 330 times pi over 180, 210 times pi over 180, 240 times pi. Like you could do every single one times pi over 180. That just gets to be a little repetitive. And so we have like common facts that we can use. Let's do our quadrant angles first. 0 degrees is how many radians? 0 degrees is how many radians? 0.
Oh.
0. 0 degrees is 0 radians. I just told you that 180 is pi radians. You remember what 90 is then? Pi divided by 2. So every 90 degrees is half a pi. So I go half a pi, 1 whole pi. What's 270 going to be?
2 pi.
3 pi over 2. Which makes 360 how many pies?
Not too bad.
4 pi over 2 or 2 pies. Very good. Very good. So all my quadrant angles are either whole numbers, pi or 2 pi, or they're halves, 1/2 pi, 3/2 pi. Okay. Which one do you want to do next? 30s, 45s, or 60s?
Third.
Okay, do you remember what 30 is as a radian?
I think it was 1/6.
Good, pi over 6. Then what we're doing in that second quadrant is we're minusing from 180 or minusing from pi. So we're essentially going 1 minus whatever your radian is. Yeah. So this is pi minus pi over 6 or 1 minus 1/6, which gives me how many 6 for 150? 5, 6. It's 1 less than the denominator. When I do my the third quadrant, I'm going a little bit more than 180. So I'm going to do 1 plus that fraction, 1 plus 1/6, which is going to be how many 6? 7 pi over 6. And then for 330, I don't really have a cute way of remembering it. It's just 11 pi over 6. Essentially, it's 2 minus your 1/6. And 2 is 12 over 6, and 12 minus 1 is 11. Okay. 45 has a nice little cute pattern. Do you remember what 45 by itself is in terms of radians? 1/4. 1/4. Pi over 4. Right, because 0 to 90 is 0 and half a pi, so half of a half is a 4th. Does anyone remember the pattern of the radians for the 45? I think I pointed it out yesterday. Pi over 4. Does anyone know what 135 is? Think about it. I'm doing 1 minus 1/4. What's my minus 1/4? 3/4. Pi. What was it? Good. So we just did 1 pi over 4. We did 3 pi over 4. Next, it's 5 pi over 4. What's the last one going to be? 7. What are those numbers? 1, 3, 5, 7. Odd numbers. So the pi over 4 is just increasing odd numbers. 1, 3, 5, 7. All right, last one. We got to do radians of 60. 30 was pi over 6. 45 was pi over 4. 60 is pi over. See how 45 goes with 4? Those match. I wish in my heart that 30 matched its denominator. I wish 60 matched its denominator, but it doesn't. They're opposite of what you think. So I remember that 60 goes with pi over 3 because I want it to be 6 and it's not what I want. It's the 3. It's opposite of what I want. Okay. What about 120? 120 is what as a radian? 2 pi over 3. 240 is what? 1 plus 1/3. 4 pi over 3. And so we had 1 pi over 3, 2 pi over 3, 4 pi over 3. What's the last one going to be? Not 6. Because 6 divided by 3 would just be 2. 5 pi over 3. Because 2 minus 1/3 would be 5/3. I know you just learned it yesterday, so I know that there's probably not a lot of sticking going on in your head right now. But there are some certain patterns and there's some things that I bet you didn't think you remembered that you remembered. Okay. We're gonna do the ordered pair for 30 and 60 right now, and then doing that, I'll prove again to you why we did 45 that way. And then you'll have a completed unit circle. The end goal is to have this memorized. The end goal is not tomorrow, but the end goal is in like the next couple weeks. So that's why I wanted to start this semester with this, so you have time to kind of work through this, okay? When you make your perfect unit circle tonight, use a reference form, but see if you can notice some patterns, some ways to start remembering this without always having to just look or do the math out. Okay? Are we gonna do what?
We always know when those other things.
We're gonna do those right now.
Oh,
So I have my special right triangles here. If you have your paper plate from yesterday, I would do it on your paper plate. Remember where we did 45 on your paper plate, do it on the back side. If you weren't here yesterday, just do it on this Notability so that you have access to it later. Okay. If you were here yesterday, what I'm gonna do first, you already have, so you can just listen, you don't have to write it down. What we did first yesterday was we reminded ourselves that with a 45-degree special right triangle, 45, 45, 90, we knew that these two legs were congruent, correct? And if you remember back in geometry, when I taught you special right triangles, we labeled these sides as X, X, and then do you remember what the hypotenuse was? 2, X root 2. So if the legs were 1, then the hypotenuse was 1 root 2. If the legs were 3, then the hypotenuse was 3 root 2. Now, if I gave you the hypotenuse, we'd have to divide by root 2 to get the legs. And since it's my unit circle, all of my hypotenuses, sorry, I know that was so extra to like cover up my unit circle, but I really wanted you to try it on your own. My unit circle goes in a way that every single one of the points on the outside is 1 unit away. And so that means my hypotenuse is 1 unit. My hypotenuse is 1. And if my hypotenuse is 1, I can do 1 equals X root 2, and I can find out what X or what both of my legs are. When I solve this, what do I do to get that X by itself? Divide by root 2. And then can I leave my answer as 1 over root 2? No, that's silly. We got to rationalize. How do you rationalize? Multiply by root 2 on top and bottom. And so X is equal to root 2 over 2. X equals root 2 over 2. That means that this leg right here is root 2 over 2. That means that this leg right here is root 2 over 2. This distance, this horizontal distance is your X value. This vertical distance is your Y value. So that's how we got root 2 over 2, comma, root 2 over 2 as my ordered pair for my 45, 45, 90. You guys okay with that? I'm not going to make you redo this. I just want you to know that I didn't just pull these numbers out of nowhere, right? Like there's a reason why these numbers work. Now you can just memorize these are the numbers that go with 45, 45, 90. Same idea for 30, 60, 90. I'm going to start by drawing my triangle where 30 is my reference angle. Then we'll kind of flip the triangle and think about it with 60 as my reference angle. Now you may not remember this. There were 3 sides for my 30, 60, 90 degree triangle as well. The side across from 30 was always labeled as X. My short leg was X. Do any of you remember what the hypotenuse was? That's the long leg, Michael. X root 3 is across from 60. What was my hypotenuse? 2x, very good. So that was the basic form that I gave you back in geometry, right? If we had the short leg, we'd multiply it by 2 to get to the hypotenuse. If you wanted to go backwards, you'd divide. If you had the short leg and you wanted the long leg, you'd multiply by root 3, kind of ringing any bells in your head. Okay. Same thing, this is the unit circle, so my hypotenuse on every single one of these triangles is 1. If my hypotenuse is 1, what's x? What's my short leg? 1/2. Now my short leg here is in referencing to my vertical distance. Is that my x or my y value of an ordered pair? Y, good. So my y for all of my 30-degree angles is 1/2. Your y for all your 30-degree angles is going to be 1/2. You guys okay with that? Okay, let's do my x then, my horizontal distance. My horizontal distance is this long leg, which is x times √3. What did we just say x was though? 1/2. What's 1/2 times √3? √3/2. That's my horizontal distance. That's the x value of my ordered pair.
Do we have to do that on the quiz?
Oh, no, so wait, do what?
The triangle map.
Okay. You will never, at this point, you won't have to reprove this to me.
Okay.
Now we're just gonna know these numbers go with the 30-degree angle. So I'm gonna come back to my unit circle and I'm gonna go put 30 for all of my, or I'm gonna go put √3/2, 1/2 for all of my 30-degree angles. Your job is to make sure your signs are good as we go though. √3/2, 1/2. When I go to the top left, I need it to be negative √3/2 and a positive 1/2. When I go to the bottom left, I need it to be negative for both of them. And then when I go to the bottom right, I need a positive x and a negative y. So we just added all of these. √3/2, 1/2. Positive, negatives, all that fun stuff. We added those blue guys. Here. Right. Now, the cool thing about the 60-degree angle is it's the same triangle as my 30-degree one, correct? It's just flipped around. I don't need to redo the math out. I'm not going to do more triangle math. I'm just going to look at my now flipped triangle to figure out what piece is what. What would my horizontal distance here be? It would be what is across from 30, and what did we say was the distance across from 30 in the other triangle? 1/2. So my x value here is 1/2. What's my vertical? What's my y distance? √3/2. It's the exact same idea as what we did on the last one, but it's a switch of that. Now it's a 1/2 comma √3/2. It's the same numbers as over here, they're just flipped. Which sometimes we think that makes it easy because you're like, oh, I have less numbers to know, but it makes it also hard. You have to know which ones go where and when to switch. So now I'm going to go to all my 60-degree angles and write 1/2 comma √3/2. Ready? Let's do it. One half goes first, √3/2 goes second. Make sure you got all your positives and negatives correct as we go. And those are the pink ones I just added. Now, you're not really ready to know this, but I need to tell you like why we're doing all of this. The whole point is that your X and your Y values mean something. The X value is your cosine, your Y value is your sine. So eventually I'm gonna say, hey, what's sine of 30? And you can go to the Y value at 30, and that's your sine. I can say, hey, what's the cosine of 135? And you can go to your unit circle, find the X value of your 135, and that's your cosine. So that's what we're getting into. And these are the important angles that are we're going to see a lot more often. And in the next 2 units, those are important facts, sine, cosine of all of these angles. And so I want us to start learning them. Okay. So I wanted us to work on this now, not when we're ready, because when we're ready is when I need you to already know them. Yes.
I was gonna ask, you don't recommend like straight memorizing, but also understanding like roots and all that?
So I'm going to tell you, everyone's brain works a little bit differently. Some of you are going to be like, I'm going to memorize this and I'm just going to be able to throw it up on the paper. Totally fine with me as long as then you can use it. I'm going to tell you that like when I learn it, I really only memorize or just try and regurgitate the first quadrant. And then from the first quadrant, I know how all the other angles, radians, ordered pairs relate to that quadrant. And then I go from there. The whole reason I spend like 2.5 days on, or 1.5 days on this is because I wanted you to not just memorize it. I wanted you to kind of know the why behind it. Because if I just wanted you to memorize it, I could have given it to you yesterday and been like, you have a memorization quiz on Friday, figure it out, right? So you should be able to understand some of this, but if your brain works in a way that you just have to memorize it, I'm okay with that too. No. I don't think your first quiz is until next Thursday is what I have penciled out. But that's all I'm saying is that like some teachers do just say like, here's the unit circle, know it. I want you to know why we know it. Okay. Okay. So your homework is to make a clean, pretty reference unit circle. That being said, we've got to do some of the next unit. Did I pass out notes yesterday?
Yeah.
Perfect. Okay, good. I was like low on notes. I was like, I don't know where they went. So go ahead and get your 4.1 notes out. We're going to do a little bit of that today. We won't finish it, so you won't have homework on that. Amelia. Yeah. Okay. Yep. Nikki, you probably need a note packet too. Anybody else not having notes or homework? I do. It's just sitting over there.
No, I have lunch right now. Every day, except for.
All right, everybody got their notes? We're just gonna do a little bit of this. We'll finish this tomorrow. Got a few vocab terms at the beginning. Some of these are silly vocab words that I don't have great definitions for, but we'll figure it out. First one is an angle. I taught you about this in geometry. It's formed by 2 rays that share a vertex. So back in geometry, I was like, okay, here's one ray. Here's another ray. And then the angle is what's in between them, right? Ray, ray, vertex. And then that's my angle in between it. Okay. Now that we're in pre-cal, I'm going to use a specific symbol to reference angle. I'm going to use essentially an O with a line through it. Does anyone know what Greek letter that is? called a theta. Many of you seen that on like Greek row, seen a theta, or maybe you have a sister or a cousin, or your mom was a theta at IU. That's a common sorority. That's a Greek symbol that we're going to use for angle, but theta is maybe something you've seen before. So I have not used it yet with you guys, but we're going to use it a little bit more often. It's the same thing as using X. It just makes it a little bit cleaner because we're going to be using X in other settings. So I like a different letter to represent my angle. Okay, now that's how we're used to seeing angles. Now we're going to do them in standard position, which is on an X and Y plane. Okay. So when it's on an X and Y plane, I'm going to draw it up here. I'm going to draw my little X and Y axes. When I draw an angle in standard position, one of your rays is always, always, always the positive X axis. That is one of your angles always. And if you remember from our unit circle, that was our 0 degree angle, which makes sense. From there, we counted all the way around, right? Your angle could stay in that first quadrant. It could go around this way. It could go around this way. It could be over here and be all of that. But at the end of the day, I'll just draw one that looks like the one before. That is my angle. It goes from the positive x-axis to wherever the other ray lays. That's called a standard position angle. We're going to do a lot of our angles like that in this chapter. The next two definitions I care about are radian and degree. Those are just measurements for an angle, okay? We already know degree. I'm going to say we know this. This is a measurement that we know. Measure. And I know it's a pretty crappy definition, but my definition for radian is another measurement for an angle.
We have to put our calculators in like the radian mode.
Mm-hmm. Not yet, but we will. Now, there's other vocab words. We're going to worry about that later. I want to remind us about our conversion factor for degrees and radians. That's what we're going to practice because we talked about it a little bit yesterday, but we didn't do a lot with it. This is on your unit circle, but I want you to have this in your note page as well. 180 degrees equals pi radians. That's like our basic conversion factor that we're going to use. Once we know that, we are then going to remind ourselves how we go from degrees to radians. And how we go from radians to degrees. When I go from degrees to radians, I'm going to take the degree that they gave me, and I'm going to multiply by, do you remember what we did yesterday to go to radians? Pi over 180. When we want to go the opposite way, when we want to go from radians, if I start with the radian and we want to go into degrees, we're going to just flip that conversion. We're going to multiply by 180 over pi. Okay. So I did show you those yesterday. We did this one a tiny bit, but we didn't do the radian one at all. So we're going to practice those too. Yes?
What is the 180 equals pi radian? So what is that?
That's just a fact we know. That's like 3 feet equals 1 yard. That's like, I don't know, 16 ounces equals 1 pound. Like that is just a conversion factor that we know. And that's how we get this and this. Okay, so let's jump down to number 3. That says convert to radians, and I want us to be exact, which means I do not want a decimal. I want a fraction, okay? So we're going to take 70 and we're going to multiply it by pi over 180. Anything you can cancel out there? The zeros, the tens, anything else? As good as it gets. 7 pi over 18. Pre-cal, I really think, can feel hard because you have to be comfortable being uncomfortable. We're going to get a lot of these kind of yucky, gross answers, and you just need to trust that like you did the math right, and that's an okay answer. Okay, let's do the other one. 120 times pi over 180. You can simplify that by a couple things. You guys get the same thing I got? Did you notice that that was one of our unit circle ones? The more you know these, and if you just see 120 and you're like, oh, I know it's 2 pi over 3, then you don't have to show me any work. Also, if you forget what the actual fraction math is, you can always do 120 times 180 to check your work or to confirm what the answer is. It takes a little bit of time, but it's a thing you can use. It's a tool you have. Okay. Let's keep it moving. We'll do degrees, minutes, seconds tomorrow. Let's go to number 5. Let's convert those degrees into radians, okay? Or those radians into degrees. These are radians and we want them to be degrees. So we're going to multiply all of them by 180 over pi. Now, sometimes when we do this, I've had kids ask like, well, how do I know which one's which, or how do I memorize that? I just think about what makes sense. If I'm in a radian, I want to make sure that my radians cancel, my pi's cancel. I can't have pi squared. So if you find yourself getting pi squared, or your pi's are not canceling out, or you have a weird pi somewhere, you probably have your wrong conversion. So this, I know that the pi goes on the bottom here, so the pi's can cancel out. I know that the zeros cancel out, so I'm just left with 9 times 18. Is that 162? Yeah. I'm gonna blindly trust that. Perfect. I blindly trusted whoever told it to me, Alpha, and I remember it. So. All right, let's do the next one. Same idea. All right, now do you notice that the last two don't have any pi's in them? That's okay. Sometimes when we do radians, sometimes they don't leave it exact and they make this a decimal or whatever. So instead of stressing out, we're still going to do what we did before. We're still going to multiply by 180 over pi. But when I do that and I get 540 over pi, I really don't want it left like this, because if I said 540 over pi degrees, does that mean anything to you? Because it doesn't mean anything to me. I have no idea what that means. So instead, I'm gonna just divide that in my calculator to kind of see if I can put some more like meaning with that. So I'll do 540 divided by pi. And don't do that 3.14 stuff. Give me actual pi. Don't round. From here, though, I'm gonna round to the first decimal. So I'll go 171.9 degrees. Okay with that? Same thing for the next one. We are going to start that next problem really quick. We probably won't finish it, but I do want to start that next problem. So the next problem on your page is talking about arcs and lengths. It's number 6 right here. 100-degree arc of a circle has a length of 7. Okay, let's draw a circle. When I'm talking about an arc, that's like the crust of a pizza, okay? The 100 degrees refers to the interior angle. So if I go from the center and I draw 2 lines out and I label that 100 degrees, this is my arc right here. And that's like the crust of my pizza. Arc equals crust. It says that it has a length of 7, so that crust is 7. And then it asks about what's the radius. What part of the picture I drew would be the radius? The little lines that make that angle, right? They're both radiuses and they're both the same length because they're both from the center to the outside, right? The formula that we're going to use here is called S equals theta R. And S is my arc length. Theta is my angle. and R is my radius. The only tricky part is that my angle cannot be in degrees, it must be in radians. Okay. So we have to put 100 degrees into radians, and then we'll use that equation. Okay. What do I do to put 100 degrees into radians? Good, multiply by pi over 180. So I'm gonna come over here. I'm gonna go 100 times pi over 180. Cancel out. It's like I can take out a 2, so I get 5/9. And then I plug my other pieces in. I know my crest, I know my arc length is 7. I know my angle is 5 pi over 9, and I don't know what R is. What do I do to find R? Good, divide by 5 pi over 9 or multiply by the reciprocal. We'll wrap that up tomorrow and review that. Remember, your only homework is a pretty unit circle.